Perfect. So we'll get started. So hello everybody. My name is Adil. I will be a co-moderator for today with my partner in crime, Michael Barton. We are excited to have you here again with us after a bit of a delay. I think we've been our webinar series since our last conference, which was in May. We had a couple around that time frame, but we took a bit of a break for the summer and obviously going into the fall as well. But more things that are coming our way. So please do stay tuned. As always, a couple of announcements. This webinar will be recorded and will be available on our YouTube channel as well. So please make sure to take a peek at that once it's complete. And lastly, we are knee deep in planning our conference for 2026. We're still sort of working out dates and location, so please do stay tuned for that as well. Again, our conference last year, or I guess earlier this year in Fredericton, was fantastic. A lot of good opportunity, and that's where we met Nicole and the team presenting today. So they were there as well. So it's a nice sort of continuation from the presentation and the work they did at the conference to bringing you this webinar here today. But before we start, I'm going to have Michael say sort of his 2 cents before we start the introductions. Michael, please.
Thank you. Well, it's actually not my 2 cents. It's a very important land acknowledgement for the people who are here, been here 10,000 years before us. Quipuktuk, salut d'Halifax, hello from Halifax. And just a reminder that Kipuktuk means Great Harbor and is actually the traditional Mi'kmaq name for what we now call Halifax here in Nova Scotia, which sits in Mi'kmaqi, or the traditional and unceded territory of the Mi'kmaq people. So, Upchilasi, bienvenue, and welcome to one and all to our talk today. And that's just for my location, but we're welcoming folks from coast to coast to coast in this great land that we call Canada and forms part of Turtle Island. So wherever you are, a very hearty welcome to our talk today. As Adil just mentioned, we had a fantastic kind of an organic introduction to some great speakers today. And if anyone ever has a great topic, even better, a topic with a speaker, and you want to contact us, hey, this might make a very interesting webinar, absolutely send that information along. We'd be more than happy to entertain it and schedule it in. But for today, just as we get going, Adil's going to do some introductions just in a sec. But as a reminder, we absolutely take questions. Typical format is a couple of minutes right now for intros, about 45 minutes-ish of content, and then we'll have the remainder, usually about 15 minutes of questions at the end. Please use the Q&A box for your questions, which I will monitor through the whole talk, not the chat box. So use the Q&A box, which we'll watch. And with that, I think we've covered most of the, you've already given a plug for next year's conference, which is great. And I think I'll turn it back over to you, Adil, to do some introductions of our great speakers today.
Wonderful. So the topic today is X-ray quality assurance. So the idea of how automation can actually enhance accuracy, efficiency, and regulation compliance in diagnostic imaging QA. So what we're hoping to achieve is insights into modern QA tools and software solutions that can transform traditional manual approaches into efficient, data-driven systems, bringing clarity, consistency, and control in our QA operations. And our speaker today is Mr. Erik Wikström. I think I got that right. So Erik, he doesn't really just teach X-ray quality assurance, he lives it. So he's the global manager of training for RTI Group Sweden, years of experience in radiological technology, and a passion for precision and safety. He has an approachable style, deep technical know-how, and he takes complex concepts and really brings it home and has the ability to clearly state them as well. His section, this is not supposed to be a lecture. This is going to be a conversation, and that's sort of the strength that Erik brings with real world scenarios, expert analysis, ensure that every attendee, and hopefully we're getting that too, walk away with tools that they can utilize immediately. So we are very excited for today's presentation. And Erik, the floor is yours. Please take it away.
Well, Adil, thank you very much. And that I must say that that flattering introduction was not my authoring. I suspect that Nicole has been in on that. But anyway, I'm very glad to be here. I'm the training manager, global training manager for RTI. So I've been around and done training in the field of X-ray testing and QA, which is RTI's home field, so to speak. Today we'll be looking a little bit at automation, how we can automate it and make cut corners a little bit to find efficiency, and also see if we can polish on the preciseness of the data that we actually collect. And like Michael was saying, let's save the questions for the end. I'll try to save some time, make room for some Q&A time towards the end. Anyway, here we go. From a global perspective, that what we see all over, I think, is no surprise to you that within the larger fields here of the diagnostic X-ray, radiography, for instance, we see an ever-growing installed base. And that's where the big growth is, and at least globally, we see the general radiography machines. So it's awareness of the risks that we're having, but also as it evolves, as the usage evolves, we get more interest into what actually is the output from the machines. How do they actually work? How do they perform? And that also is part of the QA. For fluoro, we see advancements into more complex systems, that we have lower doses, but the pulses in the pulsed fluoro, for instance, are getting shorter. That means that the amplitude gets a little bit higher. The dose rate increases. So for that, we'd also need then to keep track of that, not just the numbers of the dose, but how is the dose produced. That's also something that we need to look at, and where the interest is growing. Mammography is also growing, especially in developing countries, where we see also the beam qualities across the usage. Where it started with moly, now we see all kinds of different target filter combinations that we need to keep track of and need to be monitor that in a good way. And also with the range that we see, it's now growing into the high energies up to 49 kV, and we need to monitor that all across that whole range. So there are some tough accuracy requirements that we see, especially in mammography, because those tolerances are getting tighter. So we need to know how we can cut those corners. So what do we see here? And the components of the trends when it comes to the QA. Well, documentation, of course, has always been, but we're getting even more stringent when it comes to that. There's a bigger growing need for a QA system, not just the documents as such, but to put them into a system so that we can work with it in form to trace the data, to look at it from a historical perspective, so we can monitor and see any changes in the performance of the units over time. Time saving, of course, is always there. You see a global tendency then towards tighter schedules for QA and maintenance. Maybe not so much on the general radiography, but definitely on CTs and mammo dental machines. There's less and less time allotted for QA and maintenance and testing. So there needs to be some form of time saving in there. And of course, that puts pressure onto us in the market. How do we actually cope with this? because we need to do more in less time. So how does that compute? Well, it is a bit of a struggle, especially if you look a little bit at the background. If we look at what happens on a typical scale, when a traditional way of measuring it, you've got an instrument, you start it, fire it up, you collect your measurement data from it according to your set schedule. You transfer that data onto a report and file the report, and that's your QA system. Now, that's not very efficient. It takes time, and I mean that's something that we need to save. And there's other ways of doing it also. You can, instead of pen and paper, a modern, in air quotes, way of doing it is to do it in Excel. And still, we see quite a few users doing manual entry. So getting the data into Excel manually. Now, again, that takes time, and you have the risk of transcription error. So that's still two manual methods that are still quite common, surprisingly enough. But there is then automation, and I call it automation level 1, where we look at the possibility of transferring data directly into Excel in some way, either by making your measurements in a file, dumping all those data into an Excel file, and from there doing your computation, or by connecting to a workbook and then exposure by exposure, sending data over to Excel. That's automation level 1. And what happens there? Well, it transfers it over into your Excel spreadsheet, where it can be manipulated further and produce a report. However, we do have some challenges in there. We need to link it to the correct file so that we actually put the data in the correct file, and not only correct file, but the correct cell in the file. And furthermore, unit of measure needs to be correspond with whatever the Excel sheet is expecting. And we need to match the set values in the Excel sheet with actual technique that we're setting on the modality. So there are things in there that require some work, and that work, of course, also costs you some time. Now, we could look then at a level of automation which we call number 2, and that is looking at Ocean software. It's a software that we've developed since 2010 for this precise purpose. In that we prepare templates, and as templates, as you know, is like any old template, is a procedure, something that is prepared for a specific purpose. So we could have a number of different templates for different purposes. So we could design a template for a simple test, say a KVP accuracy test, for instance. We decide that this test should be performed in a certain way. And we put it then under the favorites button. So we click on the favorites, and up pops a collection of different templates that we had prepared in the beginning. And depending on usage and the situation, choose a template that's suitable for this. In this case, just a KVP accuracy test for user. Now, as that template loads, to ensure that we have, or to increase the probability that the user does the correct thing in the correct way, we can add instructions that pop up. And here, for instance, that this is the tool that you need for this specific test. KVP accuracy test, this is the tool that you need. To advance, we need to click OK to get beyond this information, this hint. Again, when we move further, for this specific test, there's also some how to position it. If you have some other probes that you need to connect, so you're doing it, connecting it the right way. And here again, we need to click OK to get beyond this. That means that the excuse that, oh, I didn't know, I've never seen that information, that dog simply won't hunt, because you have, in that case, clicked OK to actually, so you've removed it. You've seen it, it has been in front of you, so you've actually seen it. So that's one thing, to ensure that people get the information. The other benefit is then, of course, that if everybody sees the same information, sets uses the right setup, the same setup, chances are that the data that is being collected will correlate more. That means that the value, the quality of the data increases a little bit if we all do it the same way. And this is one way of helping that in that procedure. And once we're good to go, this is a screen that pops up where it's a well-defined process. Here we see what's going to happen. There's a grid right in there. It's small, so we have to really squint to see what's going on, but we don't have to worry about too much about that, because this is all set. We need to worry about this, what is a little bit larger here, the set values. We need to ensure that we have an SID of 50 centimeters or more, a mass of 15 or more, and we need to set a technique, kV, 50 kV, that's what we're measuring. It's a kVp accuracy test. That's the variable that we're testing. So this information is what's necessary to see. So we see this then on our laptop or our tablet, easily visible from a couple of meters away, so that we can set the technique. Okay, we're good to go. We have a ready signal, so we're good to go, a green light, and we collect the data, and after the first exposure, we have read the data from a probe which is in the field. Gives us here 49.22. The software will calculate the difference in percentage and give us then a result if it's pass or fail, based on the analysis that we have down here. As we advance, well, we might then, here's something that we, from a real good distance, see that here is something amiss. Something is wrong. We have a red signal here. It says fail. We look also at the analysis. It says fail, and it says maximum inaccuracy here at 60 kV. It's outside the limit of ±5, which we have designed into the template. So it's failing because we're outside that pass-fail limit. All right, what do? Well, we go back, redo the exposure with the correct technique, and we'll then see that, okay, it passes once we have it correct. It's within the ±5, and we're passed. We're all good to go. So that, and we're good to go and ready for 70 kV, which is the next set value that next station we're to test. And we continue with doing 70, and as we hit 80 kV, we could, if we wanted to have an additional information, a hint that pops up and says that, okay, here for this one, we need to add a copper filter on whatever, or a different technique, different calibration, focal spot, something that happens that you need a reminder. Again, we need to click OK to move beyond that point. And then when we finished everything according to this schedule, this test, which is set, we see that all lights are green. We have a pass, and that's what we're looking at. So we don't have to fiddle about any data transfer, no manual entry of it. We just need to follow the procedure. Basta così. So that is then a bit of a time saver here, where we don't have to. Everything goes directly, immediately into the database that we're looking at. So time saving, yeah. If we're doing it right, we'll do it. Save some time off the bat. Second thing we had was documentation. And once we have all the data here, there is a possibility to look at a preview of a report, which we have also then designed into the template. So as soon as we have the last one, we see pass, we can click on the preview print and get ourselves a report. Here, in this case, we have all the measurement data in here. We have a plot of where the deviation is from the set value and at the different stations. We have information about the test equipment used, the serial number of the instrument that we've been using, but there is no data here for where we were. What site did we perform this test at? That's a bit of a bummer. Anyway, well, here is a possibility to print a report also, or to make a PDF. There's an Acrobat symbol right there, so we can make an Acrobat 5 out of these 3 pages. But then again, it would be nice to document also where we were to perform this test. Now, if we have a prepared database, you see there's on the template, there's a site tab. It says site right there. So if we click on that one and open up, you have a drop-down menu where we can select already pre-made sites here, so we can pick and choose from that. And what is hidden behind these sites? Well, of course, it's the site name that we need to pick first. And once we select that, it populates all the information associated with the site name that we were looking at. So we have site, we have address, we have the contact email, we have the address. This only has one department, so that's populated immediately, but there's a choice here which room inside this department we're located in. So we need to pick and choose a room, and from there, the room has also then associated with a generator and a tube. Once we have all that, well, the report is then populated with all that information. Here we have site information, we have the tested equipment here with serial numbers, etc., and also all the rest. So we actually have a documentation of where we were, what individual modality were we working on, and what was the result of it, and what equipment did we use. So we have documented everything. So we have here, like we said, site information, and just so this is the site information that we have as a default. There's also then information here about the tested equipment, which is a generator with a serial number, make, and whatever information we have in the database for that, and the tube with the corresponding information here. Summary of the test, tube voltage accuracy test, it's a pass in that figure. Here's a nice logotype. Ocean is the name of the software, and if you don't like it, there's a possibility, of course, also of adding your own logotype to it, so you have more freedom in that. And to suit also the documentation needs, we can modify the report. See here, it's split up into a cover page and then test pages, where the different tests are, and an end note. So here we can have session title, what we want to call it, who is testing it, the tester. There's me then registered for the software, and then site information, how we want to produce that. That, as you saw, the one we saw earlier is the default version that we have. It's occupies a lot of space. But we do have, in the later version here, the possibility of choosing different section layouts for site information. Here's the default one we have, the standard, takes up a lot of space. If we choose one of the other ones here on the row, we can exclude or just focus on some other types here. And we've modified this for some states in the US which have requested it. So it's an EP form here for Texas. Their reports look like this. So we can pick and choose what we are looking at. Signature was another field that we could be modifying to suit that need. Tested equipment, when it comes to the generator, the tube, serial number, do we need all this information? Or are we happy with less information like this? And when it comes to the test equipment used, the instrument, if Piranha, Mako, Cobia, whatever it might be with the serial number, is that the type we want to look at? Or would we prefer this version of information as part of the report? Also, again, with the tests, we can modify that, the content, also to our extent. Also, um, the name or what's printed in the report. We can have test result here, English. We could make that in French, Swedish, German, or whatever, and that is what would show up on the report. So internally in the software, it would be called analysis, but an image and comments and summary or whatever. But on the report, that label could be changed to a local language. And also the texts that appear in the database could also be changed to suit that when they appear on the report. So we get a multilingual report. But the software interface is always English, but what we print on the report could be something different. Once, when we come back here in a couple of slides, you'll see an example of Thai as part of the template and the report. But anyway, so you can edit text. So there, the reports can also then be modified to improve the quality of the documentation and the consistency of the documentation and the relevance, of course, also. So what we looked at earlier was KVP accuracy test, a single test. So that's done. Rarely do we only look at that. I mean, when we do a QA, there's typically a combination of tests that we do. So in this example, we have 1, 2, 3, 4, 5, 6, 7 different tests that are then combined into one template, saying that, okay, this is what we do every year, a yearly inspection, or this is a bi-monthly or whatever it is. So we can combine different tests in this way. And where each of these tests would have an analysis, which is a built-in, there's a library of different analyses in here. So we can just pick and choose when we're building the templates, when we're designing the templates, just building it and using the built-in analyses, which are for the timer accuracy, the KVP accuracy. What else did we have here? Reproducibility, where we're looking at coefficient of variation. All of these are then built in. So all we need to do is say, yeah, we have here an exposure, and we're looking at the reproducibility. We don't have to worry about standard deviation, how we calculate that, and the average and the mean values, etc. That's already taken care of. So that built-in analysis here knows how to compute coefficient of variation based on a number of exposure data. We just pick and choose that, build it in, and then modify it as we like. Same thing with the linearity, also built-in analyses. We don't need to worry about which cell to do that, or do we need to look at it in a specific order. It will just automatically look at different MA or MAS stations and calculate the linearity based on that. Also, there's possibility of having a questionnaire, yes and no questions, and this was pretty easy. Just one question: is the tube stable in all orientations and free to move where designed? Is pass or fail? So pass, fail, yes, no, not applicable. That kind of question, that kind of reply. Also, then with an analysis built in, so we can see if it's pass or fail. And here's another one where we have a manual entry, where we key in, we measure the difference here, the measured field, we measure it, key it, punch it in by hand, because we don't have any instruments that does this for us at the moment. So we have to key in the size of the values here based on phantom or similar. But the calculations can be done in the template to give us a pass-fail based on parameters that are set. For instance, 2% of the SID for a deviation for light field and X-ray field, for instance. So these calculations are similar to what we have in Excel. So of course, this would give us a more comprehensive report. And that report can also be customized and condensed so that we have and report and document the information that we need so that we can be more concise when it comes to the documentation. Interestingly enough here that we have then the reports are customizable. So out of one set of data that we have from this template, for instance, we can have different reports or different reports templates that will give us different reports based on the same measurement data that we have. So we'll just be able to change to another report template and have another output, report output. Again, we do it once and then we're in the field and we just repeat this. We have a yearly test, yearly inspection. Well, will be the same every time for every RAD machine that we're working on, every mobile machine we're working with, that's going to be the same. So we can just do it once, one template, and then we reuse it as we go into the field. So that's then when we're looking at the documentation side of it. And that's all well and good, but traceability is also becoming a little bit more interesting. Not just having a sigh of relief that your systems have all passed the regulatory requirements. There's also being more interest in looking at data to see what we have, historical data, and see if we can see any trends as we move along. Can we predict something is going to happen? Can we compare performance of the different machines in different ways based on the data that we have? Well, since the Ocean software has a database built out of sites, which could be then hospitals or clinics, and in each site we'd have departments, radiology department, for instance, one or more departments. In each department, we can have one or more rooms, and in each room we'll have equipment, and that's typically a generator and a tube. So if we follow this structure, we can then see here and key in the RAD tube with the registration number, if there is some, the manufacturer standard, the serial number, they all have a serial number, and all any other relevant data that we may want to track. And that also then, similar thing is for the generator. Just go back a little bit. Similar thing it would have for the generator. So we could have the generator serial number and all the information in there. So that once we choose to go into a room and associate a template with a room, this will all come automatically into the report. And so we can trace that. Then once we're in there, the measurements that we do in this room will then be saved under that room together with the equipment. So these are all measurements that have been performed in this room, and whether or not it's with this specific tube or not depends on if it's active or not. So it'll pick the active tube when we're doing that. So when you replace a tube, you unclick this one and then make a new tube for the one when you serial number, and you'll trace the performance based on that tube from that point onwards. All right, now for traceability and for working with this, well, there's a trend function where we can then explore the database. We can mine the database for interesting data. And what it could be, and for that we then look at different analyses that we have built in to it, and these are all the kinds of different or some of the analyses that we can have in here. Accuracy, there's reproducibility, there's a CTI, there's what else? Half value layer, geometric efficiency if we're looking at CT, linearity, reproducibility, minimum, maximum, yeah, all kinds. So if we look at, for instance, the accuracy analyses, what accuracy have we tested? Well, we can have all kinds of different accuracy, but tube voltage accuracy is the one that we just looked at initially. So that's a common one. Let's see if we can find anything based on that. Well, if we send that query into the database, it will then come back with, okay, this is what your database has when it comes to tube voltage accuracy analyses. We can see here that it's lined up and on a timeline. And I've been most busy here, around here, which is then 2025-ish, something like that, populating my database. And here we can see them that they're all green. That means that they're within the limits. See, here's, oh, this is plus minus, must be, if we go out here, it must be plus minus 8. This must be plus 8%. But that's then based on the template that we had. The template it was working on was actually then set for maybe plus minus 10%. So for that template, this was inside. But to figure out which one is it, we can hover over the dot here, and that will then expand some information saying that, okay, this is where we were. Where was it? Well, it was in the shed. We're working on a Kodak, and yeah, that was, and it was red. And how come? Well, we can, if we click on that flag, it will then open up for us and give us the possibility to see a little bit more what was going on. And this was, oh, this was something odd happening here. And in this template, what do we have? Well, this template has a combination of, I don't know how many, 1, 2, 3, 4, 6 different tests. And one of them is the tube voltage accuracy, and that has failed for us. The other ones are passed. The other ones are okay, but the tube voltage is. So we can then go back and have a little bit more understanding of what's going on with this thing, and draw conclusions from that. So we can see where it was and when it was performed. So that's then the possibility of looking at, maybe we want to look at HVL over time. With most instruments now being able to do a one-shot HVL, we can then follow and see, do we have any deterioration in HVL as time passes? Or is it stable for this tube manufacturer? Maybe we need to look at another tube model to see, is that getting a better, flatter line, or is it has a longer expectancy when it comes to HVL, or yeah, whatever trends you might want to look at. And so yeah, those are things that you may find when you're inventorying or digging into your Excel database, your spreadsheet. But from what I understand and what my experience is, that the Excel sheets that go out and as templates, they are improved in many places. People add a line or they add a column for their own purposes, and if that's the case, then you will have quite a challenge then to mine that kind of a database in as simple as this. Of course, might be possible, but this is a convenient method, at least. That's what the way we see it, to get more out of it, not just the measurement value. So what do we have then? The final thing we had is the requirement was time savings. Well, can we see that we have any time saving? Well, if we look at it from the top here, well, what do we have? Well, we have a well-defined process for the test. It's pre-configured. We don't need to configure it, just to select it and off we go. We have the same test for all users. That's the whole idea with it. That means that you can all learn, or we can all support each other, and that way we, as a collective, save a lot of time. We can build in instructions, which makes setup faster, or it's at least enables a faster setup. Not necessarily, it depends on who is actually doing it, but it enables a faster setup. The setup is the same for all users. That means that the data will correlate better, or could correlate better. That means that we don't need to fault find as much. We have good value data all along. Built-in analysis means that we have an immediate pass and fail feedback. We don't need to worry about it. The built-in report also gives us directly the possibility to print the report as soon as we have we see the pass when we're done at the end. We have a report available immediately. All the relevant data we can pick and choose what data we want. We have different reports so that we can do that. And since it's all automated here, there is less error of transcription when we're looking at the report. And then, since we have measurements in a database here, it's easy to mine that database for interesting data, historical data, to see what's going on. And if we do this and we save time, well, instead of doing the typing and the tedious work, we can free up time for putting our minds to work. The training that was imparted during all the courses of physics and medical physics and the radiation, everything, we can put that to use to assess the data, not get the data into the report. We can actually assess the data and draw conclusions in that sense. And with that benefits, we have time also then to look at the waveforms, not just the numbers that are behind those waveforms. We can look at the waveforms and see what is actually behind the data. And here we see two different methods of approaching that, where we have nice waveforms like this, from which we can draw conclusions. How long is the actual pulse width? What is the exposure time per pulse? What is the height? What is the maximum, the peak dose rate? Does this correspond to what do we get from this? Looking at the maximum value here, the peak value here, and here, these are two different assessments, right? Or would give two different assessments. So this gives us a chance to look at that and look at the numbers and see, does that make sense? Does that reasonable, what we're looking at? Maybe we can pass something that has an iffy number because the waveforms tell a story, or the waveforms tell a different story and says that, well, maybe we need to take a second look. We'll give this a yellow light instead of a green light based on the waveforms. That's where we can put our training to use instead of worrying about typing. Another example here is for the TOMO systems in many machines. This is typically what happens, what it looks like. And here, if you difficult to make out a little bit, but if we have, what does this say? What is that KB value? What should we call this? Well, it's not a stable one. It's actually drooping like this. So it would be somewhere in between here. So it's between min and max. Is it giving us a good KD value? Yes or no? If it isn't, well, the waveform here could tell the story. So we could actually then, by using the automation features in here, we can then free up time so we can actually work in this way and let our brains do the working. And of course, for those who prefer Excel, well, there is always a connect to Excel button right here where you can export all your data to Excel and then keep on working the old-fashioned way. Just on a side note, if you go to our website and into Resource Center and under articles, you'll see a bit of a case study. Why Excel is not enough. It's from the University of Maastricht in Holland. They actually were kind enough to help us test out parts of the Ocean Next software. And what their experience was that it's what used to take them 3 or 4 hours is now taking them about 25, less than half an hour, about 25 minutes. So that's a customer actually saying that when it comes to saving time. So I think that's one interesting effect of the automation in X-ray QA. So with that, well, I'm pretty I don't have any slides left. So if you have any questions there in your Q&A box, that would be time to inventory them right now.
Thank you, Eric. That was very informative. Very, very interesting. People, I think, are a little shy with submitting their questions at the moment, but I have some, of course, and Deal, obviously, you chime in as well to ask questions. Um, I love the fact that there are a number of different formats that you can store. I'm assuming because of all those different formats, it shouldn't be hard at all to accommodate a various number of different quality assurance or like work order systems. So that's wonderful. Everyone has a different way of doing things. Um, I love the storage of things into, I believe you mentioned they're shareable files. Um, can we talk about that a little more? And let's take an example of, say you have uh, the group of radiologists, et cetera, for BC or for Ontario. So we have many different districts in both of those provinces. And if at a provincial level they get together and say, hey, this class of tests or this class of devices, we have an explosion of interventional radiology suites as well as hybrid wires. And really the pressures on using those systems is really going through the roof. Therefore, the pressures of having things work properly are also higher and higher and higher. And oh, by the way, it's an OR, so you can't have your typical half a day. We're going to give you the 30 minutes before we start at 7:30 in the morning. So would you like to just talk for a couple of minutes? Say, hey, say at a provincial level, if you want to get together as your department heads and share templates to make sure everyone is doing the right thing, the
Oh
correct
yeah,
thing.
yeah, and that's what we saw from your colleagues there in Maastricht in Holland, um, where they were working with Excel previously and they had everything like that, and then they went over to Ocean, and that was a help for them. But they then jumped on the bandwagon with we have a cloud service where we can actually then share measurement data via the cloud. So the guy you see here is Ralph Gielan. He's the guy holding it all together. So he collects from his 6 colleagues and whatever he does himself. He collects those measurement data into one big database file where he can work in that way. And I'll see if I can get this working right now. Go. Take some time for the screen to adapt, I think. But what we do is the templates as such are shareable, of course. The minimum level for that is you can share the template as an attachment to an email. So you can just export that. You can also then, once that's populated, once you've used that and filled it out with data, that filled out measurement session, as we call it, will then be shareable as well, exportable by email initially. So I was hoping that this would wake up a little bit sooner. I think that there we go. So I think you can see my screen now. This is the Ocean screen, right? Okay. So what we did just now was that we were at this hospital here, Aarhus. We had Canada 1 as our test. Is that visible at all? All right. So by right-clicking on it, I can then either start a new measurement based on that template and just toss out all the old data. I can export it as an attachment to an email. And I can then also share it via the service that we call My Box. So that's what our friends there in Holland are doing. They're sharing it via my box in there. So now we've got many screens off. There we go. So here we can then have that. We can share it, either save it as a file onto the file system, or share it via email to one or more, or broadcast it wherever we want it to be. We can also then share via this MyBox service. So I will determine who receives it. And that, of course, requires everybody to have a MyBox subscription in there, and you'll be notified. If you don't have a subscription, you'll be notified that, hey, Michael wants to share data with you. Do you trust him? And I'm sure most people would. And then click OK, and then you'd be in that system where you just receive data that way in there. So those are two ways of doing it, and that applies to the templates and to already set measurement files. That means that you can combine those things in a smart way.
Cool, thank you. Okay, we have a couple of questions in the box now. And any questions we don't get to during the session itself, we will, Erik and Nicole, if you're amenable, we'll send the questions to you, get answers, and then email out to the attendees if you're okay. Fantastic. Okay. Nicole, I wonder if this is a better question for you. Where can I reach a rep in Canada? Oh, Nicole is typing the answer. Okay. I suspect Nicole has that very well in hand. So given we're at 1:53 or 12:53, let's go on to the next question. Thank you for conducting this. Is there a limit on the number of user licenses for the software?
The software itself, like we said here, is license free. You can go to our website and download it and use it. What we do have is a license or a charge for the MyBox service, the cloud functionality. So that's at the moment it's a 6 months trial period, and so you can try it out, see if it's worth anything, and at least you'll get out of it is cloud backup of your database. So if your laptop goes missing, you can just replicate and restore everything, and you can also then share to other people in that.
Cool.
But the basic software is free of charge.
Two quick software related questions for software. First of all, you talk about cloud. So is the software available for use offline, or is it only online?
Offline, basically, and then you have a synchronization engine so that
great.
Because when you go into CT chambers, CT dungeons are usually little coverage in there. So we have if you don't have any coverage, if you're offline totally, once you get back online, it will replicate the database and just push up the whatever new measurements you have.
Fantastic. And I see Nicole answered the other software question, which is, are you Win 11 compatible? And she clarified, yes, Win 10 and Win 11 compatible, which is great. And then, here's a tricky question. Is this registered as a software as a medical device, an SAMD, with Health Canada? And what's the risk classification?
Well, I'm not 100% sure about Canada, but this is not classified as a medical device.
I didn't think it would be.
We don't. There's no patient data in there. Nothing at all. It's like a DVM, something like that, with some more information about where it was actually used and history in it. Also, the instruments that we have as part of the package, they're also not medical devices. Is like a spanner, a wrench, screwdriver. It's not in contact with the patient, thus it's not a medical device.
Right. That's where my brain went. I was pretty sure you're going to say that. Given we are talking about trending data and maintenance data, etc., I will assume that as more groups have products like this online, as part of their maintenance systems for documentation. I'm thinking if it's not already, at some point in the not too distant future, when we go through accreditation, et cetera, the accreditors are going to be expecting us to have some similar documentation being used. And so if they want to say, hey, you know what, pick a certain file, certain day, certain time when you did your testing, I want to see all your test results for that day to make sure you're doing appropriate ongoing QA testing, et cetera.
Yeah, well, that's we had a good example of one of our managers as he joined, he tagged along with one of our customers, and who was independent. So he did QA testing, independent medical physicist. So he did testing along the way, and it was called up by a client of his, a hospital, and they were being audited, and called him up and said, "Hey, okay, we're in trouble. We can't find this the report that you sent us 6 years ago. Do you have it on file?" And he said, "Well, maybe let me check. This is going to be really, really tricky. I might have to bill you for it." And then he said, "But I'll call you back." So he pulled out his laptop, just went into the database, and there he found it, printed a PDF report, and then emailed it together with an invoice of a couple of $100. So, I mean, that's the beauty of having it online, or having it available digitally.
Wonderful. Almost along the same lines, but a flip of the coin. So I would think my very first job that I did way back in 1998, I was radiological services maintenance manager in St. John, New Brunswick. So big thing that I was doing was working with the repair techs, et cetera, to make sure that not just the systems were PM'd appropriately, but if a tube actually had premature failure, work through the insurance, et cetera, to get some amortized payment back, et cetera. I would think if you keep up with your data, with your testing, and have this excellent data to support it, we could do even better cost recovery or amortized tube replacements.
Well, that's one thing that you might be able to check, but you'd also be able to double check exactly what you're saying, because you have that on file. You have before, you have after, and this is what we're doing and we've been doing. If you have the maintenance, the biomeds doing the maintenance, the preventive maintenance, recording their measurements, you have everything on file. And you have a database here, you can pull up that room and they can check all the checks, not only the QA, but the preventive maintenance HVL testing. That goes into the same basket. So you can double check all that. But once they've been there on service, when you call them up and say that, "Hey, I'm getting a funny waveform here, it looks odd, could you come fix it?" And they come, they fix it, and they go back. You can then look and see, is it fixed or not? Have they corrected for that overshoot or not? And they say, "Yeah, everything is dandy." Well, then you can just do your measurement, pull out and look at the waveform, print the waveform and say, "Hey, no, I'm not paying the bill because it's still not fixed. You can come here and do it right." But that's another possibility. And then without having to run, I mean, you don't have to worry too much. We do have, as a matter of fact, up in some hospitals here in Sweden, up in the way in north, I'm sure you're familiar with that, where it's not very densely populated. There's a lot of this. You have one medical physicist, and there's a radius of maybe 150 kilometers or something like that. And they don't want to go there and double check once the service has been done.
Mm-hmm.
So they actually accept ocean files from the manufacturer as proof of job done.
Excellent. I'm sure our colleague Kevin Taylor up in Northwest Territories would very much appreciate that aspect. There's one more question, but it looks like it's an involved one. And it's how does the ocean software connect with the new Mako compared to the Piranha? That looks like maybe it would benefit from a more at length written response from you. As well, we're at 201. 101 for those in Central.
Same thing. It will just, if you have the latest, what you need is the latest software version, Ocean 4.4, and or Ocean 4. And the Mako connects just as and does the same thing. It inherits the same old templates from Piranha and everything, so it's just plug and play.
Well, that's excellent. With that, I would thank Erik very, very much for a fascinating talk today. Nicole, would you like to have some closing remarks?
Yeah, that was a great presentation, Erik. Thank you so much for sharing those details on X-ray QA automation. And thank you everybody that attended. And if there's any further questions after the webinar, please feel free to reach out.
Wonderful. Adil, final remarks to you.
Final remarks. Again, thank you, everybody. More to come from our end as well. And please reach out to myself, Michael, for any questions you guys do have with respect to the webinar today, and to Erik and to Nicole as well. Otherwise, signing off. Have a great Tuesday, everybody.
Thanks, everyone. Merci tout le monde.
Bye-bye.
Bye.